All right, welcome back. We're going to get through problems 10 through 17 on this video. And hopefully it won't take 20 minutes, but you know what? I'm happy to do it for you as long as you benefit from it. Okay, so with this problem, I started to kind of go down one path and it didn't work for me, so I backed up and tried a different path. The first thing I knew is that the properties of radicals would allow me to rewrite this as radical 18 over radical 42. And then I looked at it and I said, I could solve this, but I'd really kind of rather not deal with this. Neither one is a perfect square. So I said, you know what, let me try something else. I said, how about if I simplify 18 over 42? And I could divide the top and the bottom by 6 and get 3 over 7, but that's not going to give me any perfect squares either. So I simplified it only to 9 over 21, because hey, I know 9 is a perfect square, so I can simplify that part easily. So now this is equal to radical 9 over radical 21. And now I can simplify. Radical 9 is equal to 3 over radical 21. But I'm not done, right? Because I have a radical in the denominator. I'm not allowed to do that. So I'm going to rationalize the denominator. To do that, I'm going to multiply my fraction by a form of 1. Right? We do that all the time. If I have 3/4 and I need eighths, then I'm going to multiply this by 2 over 2, right? And then that's going to give me 6/8. Right? We do that all the time with fractions. Because 2 over 2 is equal to 1, I'm allowed to do that. So what fraction equal to 1 would get rid of this radical? Radical 21. I'm going to multiply it by that radical. So radical 21 over radical 21. And now here's something someplace where some people mess up. They think radical 21 times radical 21 equals 1. It does not. Two ways of thinking about that. Radical 21 times radical 21 is radical 21 squared, right? And these are opposite operations. So I could cancel those out. And what am I left with? 21. Or another way to look at this is if I had radical 9, pretend that's a radical sign, times radical 9, that's equal to 9. And if you want proof, what's radical 9? 3, right? 3 times 3 equals 9. It works out. Because they're opposite operations. All right. So now that I do that, I'll end up with the numerator 3 radical 21 over 21 for the reasons we just talked about. I'm still not done simplifying because now I can reduce my fraction a little bit and I get radical 21 over 7. There's my answer, A. To practice this, I recommend EE1 through EE7. That means anything in between. All right, number 11. Find the simplified form of the following expression, assuming, once again, we're making sure that we don't have zeros in the denominator. Okay, let me rewrite my expression. Okay. Now the properties, just like the properties of radicals said, I can break it into its individual components, the numerator and the denominator, and deal with a radical separately. I can do the same thing with the exponent, right? Because they're inverse operations. Oh, I was saying opposite operations before. I'm so sorry. Inverse operations. Anyway, so I'm going to go ahead and take the numerator and raise that to the power of negative 2, and do the same thing to the denominator. Raise that to the power of negative 2. And I could flip my expressions, but I see that I'm going to end up dealing with that anyway later. So for now, I'm just going to go ahead and I'm going to multiply each factor to the power of negative 2. I'm going to raise each factor to the power of negative 2. So 2 to the power of negative 2. Let me back up on that. I was a bit fast. 2 to the power of negative 2 is pretty clearly 2 to the power of negative 2. X to the power of negative 4 to the power of negative 2. Remember, we multiply those exponents, gives me x to the power of 8. y to the power of 5 to the power of negative 2, multiply y to the power of negative 10. Z to the power of 3 to the power of negative 2 gives me z to the power of negative 6. Over x to the power of 7 to the power of negative 2 gives me x to the power of negative 14. Y to the power of negative 2 gives me y to the power of negative 2. And z to the power of 0 to the power of negative 2, well, that's going to be 0 times, that's going to be z to the power of 0. Even before that, what is any non-zero number? Remember this part. What is any non-zero number to the power of 0? 1. So I have 1 to the power of negative 2. That's just 1. And so in the midst of all this, I can just ignore the fact that that 1 is there. It doesn't influence anything. All right. Now I'm going to start dealing with my negative exponents. Just flip them to the opposite part of the fraction. So in the denominator, I'm going to have 2 squared. Once again, I'm crossing off my factors as I deal with them. X to the power of 8 times x to the power of 14, because I moved up my negative 14. Y to the power of negative 10 divided by y to the power of negative 2. I'm just going to reverse those. Y squared over y to the power of 10. And z to the power of negative 6, I'm going to move that to the denominator, z to the power of 6. And now I'm going to cancel out my like term. I'm either going to combine my like factors or I'm going to cancel out my like factors. So that is equal to, well, 2 squared is 4. X to the power of 8 times x to the power of 14 is x to the power of 22. Forgot to cross those out. Give me a second here. There we go. Y to the power of 2 divided by y to the power of 10. Well, I can subtract. Gives me y to the power of 8. Z to the power of 6. There we go, z to the power of 6. And now I have my answer. To practice this, V5 and V3 would be your best bets. Could I have solved this other ways? Yeah. Lots of you, as I was doing this, probably thought, well, I would have done, that's fine. As long as you're getting to the right answer. As long as you're following the rules, you're okay. All right, which of the following expressions is equivalent to this expression? Don't stress out too much about this, but let's go ahead and go through it. There is that whole expression. Give me a minute. It's a long one. All right. Order of operations. I'm going to work from the inside out for each one. Inside out. Inside out. Okay. So 3 to the power of negative 1 to the power of negative 2 gives me 3 squared. X to the power of 0 to the power of negative 2 gives me x to the power of 0. Yes, I could have dropped this out now because it equals 1. Whatever, I left it there. There's no harm. Plus 2 to the power of negative 3 times y to the power of 0 to the power of negative 3 is y to the power of 0. Minus 5 times 3 times, well, what's going to be in here? 1/3 x to the power of 3 to the power of 0. Hey, any non-zero to the power of 0 is what? 1. There we go. It doesn't matter how much stuff is in here, because if once I raise it to the power of 0, it becomes 1. All right. Well, let's go ahead and deal with some of this crud over here. So 3 squared is 9. Do I care about this x to the power of 0? No, it's 1. 9 times 1 is 9. Okay, plus 2 to the power of negative 3 is 1 over 2 cubed. Once again, I can cancel out that y to the power of 0 because it's equal to 1. Minus 5 times 3 times 1. Okay, going extra slow on this one. And we can continue simplifying. I'm going to deal with 2 to the power of 3, and I'm going to multiply 5 and 3. So that equals 9, plus 1 over 8, minus 15. Now it's a matter of simple arithmetic. That equals negative 5 and 7/8. There's my answer. Once again, V9 actually is probably going to be your best bet on this one. Number 13. Most of you got this right. Well done. Moving company sells boxes for packing items. We have a volume of large box. We have a volume of a medium box. Customer buys 2 large boxes and 1 medium box. The way I dealt with it is I went ahead and I decided to multiply 2 times the volume of a large box. So I'm multiplying this polynomial by a monomial. Really simple. I just need to distribute this 2 to each term, right? So I end up with 12x cubed plus 4x squared plus 6. And now I'm going to add that to a medium box. And when I do that, I'm going to leave space. So I'm going in standard order, and I'm dealing with x cubed, x squared, x to the power of 1, which I don't have, and then x to the power of 0. So I'm going to go ahead and put a placeholder there. And now my medium box to add. And now I can just add each column together. Now a student asked, couldn't I have just taken a large box plus a large box plus a medium box? Sure, same thing. I doubt it, but if you do need to practice this, Z4 or Z6 will get you there. Number 14. What is the product of these binomials? Man, you guys rock this. What method do I use when I have binomials? Is I can just use FOIL. Remember, that only works for a pair of binomials being multiplied. If you have a polynomial, you have to distribute each and every term in each part. Well, that's really what FOIL is doing. The FOIL just gives us a system to do it. All right, so first, r times r gives me r squared. Outside, r times 5 gives me 5r. Inside, negative 8 times r gives me negative 8r. Last, negative 8 times 5 gives me negative 40. Combine my like terms, I get r squared minus 3r minus 40. There's my answer. Practice would be Z8. Okay, once again, you did well on this one. I'm not sure, though, did you do it the long way or did you remember the easier way? Because this is a special case, right? This is a binomial squared. So you might have remembered the pattern. A plus b squared is equal to a squared plus 2ab plus b squared. If you didn't remember that, that's okay. You can just multiply them out. B plus 7 times b plus 7. Multiply my firsts give me b squared. My outsides give me 7b. My insides also give me plus 7b. And my lasts give me plus 49. Combine like terms, I have b squared plus 14b plus 49. Forgive me if I'm going a little fast on this, but I think by now we're all at the point where we know these things. So there's our answer. And good practice would be Z8. So even if I go fast when I'm saying it out loud, I'm still showing you the work when I'm writing it. Okay, so just rewind if you're like, wait, what did she just do? Rewind and watch again. I will shut up and continue doing math. Number 16, the polynomial is factorable. Good to know. One factor is x plus 6. What's the other factor? Really? They made this one really easy for us. So there's my original polynomial, x squared plus 11x plus 30. And I'm going to factor it into two binomials. It gave us one of them, didn't it? X plus 6. So now all we need to figure out is what's going to be this binomial. Well, we know we have to put x here because x times x gives us that x squared. The only question left is what goes here. Well, we need a number. 6 times something gives us 30. We don't have a lot of options. But we also need to make sure 6 plus that something has to give us 11. And it's 5. And we're adding it. And that's our other factor. There is our answer. You can practice using AA8. Last problem on this video. Hey, it's not going to be 20 minutes. Which of the following is a factor of 3x squared minus 12? Once again, I went down the wrong path first. Here's what I did. 3x squared minus 12. If I factor that into two binomials, I get 3x and x, because if I multiply those, I'll get 3x squared. And now what's going to go? And then I kind of realized, why am I going this way? I forgot something. I forgot to take out the greatest common factor. There's a greatest common factor here, so forget that. Greatest common factor is 3. So if I factor 3 out, I get 3 times x squared minus 4, right? That is equal, right? And now I'm going to say, well, that's 3 times the product of 2 binomials, and figure out what those binomials are. Well, the first term of both has to be x, and I might recognize this as the difference of squares. So I'm x plus 2 times x minus 2. And now I can see which one of these, there we go, see, x minus 2 is a factor. To practice AA8. Alright, see you in the next video. Have a good night, and I'll see you in class.